Hey everybody, in this video I'm going to show you how to do the Wilcoxon sign rank test. This information about this test appears in our book, Basic Statistics for the Behavioral and Social Sciences Using R, and more information about this test can be found in Chapter 7 of our book, which discusses non-parametric tests of central tendency. So the Wilcoxon sign rank test is the non-parametric equivalent of the paired sample t-test, which we discussed in Chapter 6. And you would want to use this when your observations aren't independent. So for example, if you look at a person at two different time points, one time point is not independent of the other because it's within the same person. And that's the example that we're going to be using. You could also use it, say, for if you collected data from a husband and wife in the same setting, or something of that nature where observations are not independent of one another. But what I'm going to show you now is fairly typical, that we're going to look at data within the same person across two different time points. You would also want to use this non-parametric test when sample sizes are small and you can't assume normality. So this is a different type of test than the paired sample t-test, but it does give us a similar idea if there are significant differences across the time periods. So what this test does is ranks the observations from one, across the time points, and then looks at the sums of those ranks. If the differences exist, so if there are significant differences from time 1 to time 2, we would see most of the low ranks in one of the time periods and more of the high ranks in another. If there were no differences, we would see a mixture of those. So for this example, we're going to use the hospital data set that comes with the textbook. And you could probably assume independence of observations with 50 participants, but we are going to be more conservative in this case and not do that. Some people also may argue that 50 is not an insufficient number. So there are two variables in here. These are hospital patients, and we looked at the memory of patients at admission to the hospital and also at discharge. And the question is did people's memories change after discharge? Higher values in this scale are better. So what we can do is we can start by taking a look at the median values of both of these variables. So I'm going to type into the console here. What I want to do first is attach the data set. And again, this is sort of a questionable practice by some, but this is for example purposes only and saves me some keystrokes. So I'm going to type in median and type in mem before. And I'm going to put in na.rm equals true. If I didn't do that and we had missing values, which we don't have in this data set, but this is a good example, we would get an error because of the missing values. We wouldn't know what to do with them. But the median memory score for patients admitted at the hospital is 16. And I'm going to use my up arrow to save myself some keystrokes because I tend to type incorrectly, and change mem before to mem after. And it looks like median values did change from 16 to 18. Now the question we have is, are those significant differences? So we can do that using the Wilcoxon sign rank test, and we're going to simply type in wilcox.test and mem before, comma, mem after. And this is going to look a lot like the Mann-Whitney U. So far, this looks like what we entered for that. But we're going to note the paired nature of this data and say paired equals T. We could type true, but we're going to just do T. And if we hit enter, now we get some warning messages because there are ties. So that we get that sort of warning message, but we don't need to worry about that. So the data that we are using, you can see that this is the Wilcoxon sign rank test. And the data we're using is both mem before and mem after. And indeed, our p-value is less than 0.5. So that median change from 16 to 18 is statistically significant. And you'll notice that the output from this test is different from the Mann-Whitney U that we did earlier. Besides the title, you'll see the test statistic is different as well. So hope you enjoyed this video. Hope you found this helpful. And thanks to one of our viewers, they asked that I make the script a little bit bigger so you can see it better. So hopefully this is helpful to you all.